Hey guys, this is Academic Chemistry, Chapter 5, Section 2, Part 1. So this is arrangement of the electrons. This is going to be the first lesson to really talk about electron configuration. You're going to notice a lot of similarities between the activity where you figured out like what dorm rooms all the students lived in to where the electrons go. And oh my gosh, you were actually doing electron configuration in that activity and you didn't even know it. So let's go ahead and jump right in. So a reminder of the orbital shapes. So we have four different shapes. Now, some of them get a little funky and they have different orientations. So there is one orbital for S, which is that spherical looking thing. There are three different P based on you have one that goes on the X direction, one in the Y, and one in the Z, which comes in and out of the plane. You have five different Ds and seven different F options. Now, not all of these are available in every energy level. So if we looked at the atom here, in our first energy level, in this first area outside of the nucleus, that's the first energy level, you just have S. That's all you have available. So if you have any electrons there, that's definitely where they're going to go. In the second energy level, so right here in this area, there is an S available. There's also a p orbital, a p, and another p. So if you notice, this is your first energy level, right? Just this guy, this S. Your second energy level has this option as well as the p's. So these first two lines are also available. Notice this S in the first energy level is different from this S in the second energy level. They have the same shape, but the second energy level S is larger. So you have an S spherical pattern in the first energy level and then a bigger S spherical pattern in the second energy level, which is a completely different orbital. All right, in the third energy level, you're going to have an S, P, 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 and you also have 5D options, D, 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 D. Okay, so you've in the third energy level, you have this S, these P's, and these D's. So in the fourth energy level, and for any energy level thereon, you would have all four options. S, P, 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 D, 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 and F, 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 F. So those are all the orbitals in the first four energy levels. Any energy level bigger than that, so fifth, sixth, seventh, would look like the fourth, except for you don't end up having the F energy levels past the fifth, just because the atom gets too big and too crazy for what we can handle right now in current nuclear chemistry. Remember the rule that each of these orbitals, so each of these letters that I've drawn in here, these are all orbitals I've labeled, can hold a maximum of 2 electrons. So this 2s here, second energy level S shape can hold 2. This 2p can hold 2. This 2p can hold 2. This 2p can hold 2. And we're going to go through those in a bit to remember. All right, so sulfur. If I wanted to know sulfur's electron configuration, the very first thing I'm going to do is find it on the periodic table. So please make sure you have a periodic table. If you don't, go ahead and freeze this video and get your chemistry biff out, your best friend forever. All right, so you should have found sulfur, which looks like this. Now, if you notice, there's no charge on this sulfur. So the atomic number here, that's your counting numbers, and it's the order the periodic table goes in. Sulfur is atomic number 16, which means it has 16 protons. In a neutral atom, and for the first few lessons in this chapter, we're only going to talk about the electron configuration of neutral atoms. The number of protons and electrons have to be equal. So if there's 16 protons, there has to be 16 electrons. All right, I'm going to give you the electron configuration, and then we're going to talk about what it means before we learn how to build it. So the electron configuration is, the way you read it, 1s2, 2s2, 2p6, 3s2, 3p4. Okay, what does that mean? So the big numbers are your energy levels. You might be saying, what are the big numbers? All right, here they are in red. So this 1 here, this 2, this 2, this 3, and that 3, those are the energy levels, meaning how far away from the nucleus. The letters are the orbital shape. So in the first energy level, you have an S. In the second energy level, you have an S. In the second energy level, you have a P. In the third, you have an S. In the third, you have a P. The superscripts tell you how many electrons. So you've got 2, 2, 6, 2, 4. So what does this mean exactly? So this 1s2 means that in the first energy level, so right outside of the nucleus, there are 2 electrons in an s orbital. Remember, this top number tells you how many electrons. This 2s2, 2p6 tells me in the second energy level, there are 2 electrons in the s, so there's an s orbital with 2 electrons, and there's 6 total electrons in that p orbital. Now you do have 3 different orbitals for p's, it just counts them all together. So even though each orbital has 2 electrons, you just clump them all together to say 2p6. And then this part, it's saying in the third energy level, I've got electrons in an s orbital and a p, and I've got 2 of those electrons in s and 4 in p. Okay, so what if you didn't know that this was sulfur? So we already did this example, so that's the way you know it's true. So what if I had just given you this electron configuration? Well, how could you tell what element it is? You know that it's neutral because I haven't told you a charge. I would always tell you. So what you're going to do is add up all the superscripts, right? So these numbers up here tell you how many electrons. So you can just add them up to get the total number of electrons. So that would be 2 plus 2 plus 4 plus 2 plus 4, and that's 16. So that brings you back to the periodic table. That's the way to either check your answer after you write out an electron configuration, make sure it's correct, or if you're given an electron configuration and we say what element is it, add up the superscripts. So speaking of which, here are 4 examples. I want you to freeze this video, take out your periodic table, and try and figure out which element each of these examples is talking about, A, B, C, and D here. So you have to freeze the video, try it yourself, and then come back and see if you're right. Okay, so you should have frozen the video. And 1s2, 2s2, that would be 2 plus 2, which is 4. So you look on your periodic table and you go to the atomic number 4. Now this is talking about 4 electrons, and I know the atomic number talks about the number of protons, but since this atom is neutral, protons and electrons have to be the same. So this would be beryllium. All right, for part B, you add up all those top numbers. You should get 31. 31 on the periodic table, that is gallium. Okay, for part C, you add them up. 3, lithium. Part D, add them up. 17, chlorine. Now, if you want to come up with your own electron configuration, you're going to want a way to know what order they go in. So here's a handy dandy chart that is easy to use. I know it's printed out for you on your notes, but it's really easy to write out too. So see how it goes 1, 2, 3, 4, 5, 6, 7, 8, right? And then you think about what orbitals does each one have. The first one has S, second energy level has SP, third energy level SPD, fourth SPDF, 5, and then from then on, sorry, SPDF. They slowly taper off at the end, but it doesn't matter if you put extra, it'll still work. So how do you use this? So you use this chart to figure out what energy levels and subshells fill first, and you do that by drawing in arrows. So you're going to draw an arrow on the diagonal here. So it's going down and to the left, so you can see what order it fills in. So 1s fills first, because that's the first arrow you would hit. Now you must completely fill a subshell or orbital types before you move on to the next subshell. So if you only have 1 electron, for example, it has to go in 1s. You can't move on. If you have 2 electrons, both of them have to go in 1s. You can't move on to the next one until 1s is totally filled. And this is like that electron dorm activity where you had to give people roommates before going on to the more expensive dorm. That's because it takes energy to be further away from the nucleus. So the way these fill is in the lowest energy orbital possible. You want to fill the low energy orbitals with electrons before the outer. That's just how it works in nature. Electrons want to be in whatever the lowest energy level configuration there is. So your arrows kind of look like this. So see how it's doing that diagonal and down. So 1s fills first, then 2s. And if you look at the arrows, the next one would be 2p. And then that leads you to 3s. So once 2p fills, you can go to 3s. From there, see how your next arrow kind of leads you to 3p, which leads you to 4s. And again, all of these have to completely fill before moving on to the next one. Notice 3p fills, then 4s fills, then you go back to the third energy level, to the 3D. So that's why this chart is handy. It helps remind you that you have to go back to 3D after 4s. 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p, 8s, 6f, 7d, 8p. So that is your electron filling orbital, electron filling order. And the biggest thing is you have to completely fill a subshell to move on. So for S, maximum are 2 electrons because there's 1 orbital, 2 electrons each. For P, the maximum number of electrons you can put in there is 6. There are 3 p orbitals, 2 electrons each. 3 times 2 is 6. For D, there are 5 orbitals possible. So 5 of those structures that look kind of like a flower. So if there are 5 orbitals and you can put 2 electrons in each orbital, how many electrons do you think you would need to completely fill any D subshell? Well, it would be 10. Okay, and then 14 for F because there are 7 orbitals, 2 electrons. Okay, so let's do some practice. What is the electron configuration for magnesium? So the first thing you need to do is find magnesium on your periodic table. So once you find magnesium, you can say how many electrons, and that's going to be the same as the atomic number because the protons and electrons have to be equal in a neutral atom. So that's 12 electrons. So you have 12 electrons that you need to place somewhere on this board over here. Where are they? Well, you always start with the lowest energy, so first energy level, and an S. So you always start with one S. And also your arrows tell you to do that too. So if you forgot, that arrow helps. So okay, write 1s. How many electrons can fit in this 1s? Well, 2 electrons can fit. Do you have 2 electrons to place? You do. So there you go, 2. You've used 2 of your 12 electrons or placed them, said where they go. So you have 10 left. What's the next one? Okay, my next arrow is 2s. So I write 2s. How many electrons can fit in any any s shell? Well, 2. So 2s2. What comes next? 2p. I've used 4 electrons in placements. So out of my 12, I now have 8 left. 2p can fit 6. So my 2p gets a 6. The next orbital would be 3s. So you go ahead and write 3s. I've only placed 10 electrons out of my 12. I can fit 2 in my 3s. So I give it a 2. So here's my electron configuration. 1s2, 2s2, 2p6, 3s2. You can also add these up to double check yourself at the end. 2 plus 2 plus 6 plus 2 is 12. So you're good. All right, what is the electron configuration for nitrogen? So you have to find nitrogen on your periodic table to find the atomic number. How many electrons? Same as the atomic number, 7. You have 7 electrons to place on this map. Where do you always start? 1s. So go ahead and write your 1s. How many electrons can fit in 1s? 2. Do you have 2 electrons to work with? Yeah, you've got 7. So 2, and put that 2 as a superscript to tell you how many. So out of these 7 electrons, you've placed 2 of them in your 1s, so you have 5 more to go. The next orbital to fill is 2s, so you write your 2s. That's the second energy level in an S shape. And all s's can always have 2 electrons. So do you have 2 more? Yeah, we have 5 left to place, so I can put 2. So out of my 7, I've placed 2 and 2, which is 4, so I have 3 left. What's the next one? 2p. So you write your 2p. And how many electrons can fit in a p orbital? 6. But do we have 6 electrons? I only have 3. So you write the 3 up here. You don't have 6 to place because you only have 7 total. 2 plus 2 plus 6 would have given you 10. It's 2 plus 2 plus 3 that gives you your total number of 7 electrons. So 1s2, 2s2, 2p3 is the electron configuration for nitrogen. All right, so now it's your turn to do a kind of longer one on your own. What is the electron configuration for zirconium? So you need to first find that on your periodic table, figure out the atomic number, and then go in order. How many can fit in each? Remember, any s orbital can get 2, any p can get 6, any d can get 10, and any f can get 14. All right, freeze your video and come back in a second when you have the answer and see if you're right. If you're not, definitely talk to your teacher to see what happened. And if you are, awesome. Okay, so you should have frozen the video. Here is the electron configuration for zirconium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d2. Okay, hope that went well. If not, definitely talk to a teacher before you get any further along, and I'll see you in the next lesson.